Hello, everybody. My name is Clemens Jütte, and I'm a platform architect at Humanitec. Today, we're going to have a talk about dynamic configuration management, or DCM, the art of dynamically generating app and infrastructure configs with every deployment. That drives standardization, self-service, and clarity on ownership. First of all, we're going to have a look at why interface choice is important and dominant in every Humanitec product. And for that, I'm going to show you a score file because score is the code-based interface for developers. This is a very simple score file, but it actually has everything that makes score score. So score, first of all, is an environment agnostic workload specification. You will not see any specifics in this file which point to a singular environment. Instead, you can use it with every environment. Today we are reasoning about a service called whale-say. And to be able to actually show you something, I need to get the networking right. So inside and outside port of my container, I need to specify that. And there's no development happening today, but we're going to directly deploy this one here from Docker Hub. And as every good demo, we're going to say hello to the world. And because I hate typing IP addresses, I'm going to ask the platform to supply me with a DNS record. I'm not going to dive deeper into Score here because there's going to be other tutorials on Score. Feel free to have a look or even read up on Score, the open source project. And you can find that at score.dev. And if you look around here, one stop should be the docs, the reference, and the Score specification, where you can read yourself into all of the nifty little details of the project. Okay, great. Now that you've seen a score file, we can see what a score file actually does to the environment that we're going to have a look at. And to actually have something to look at, we first of all need an application because an application is a container for services, like the service you have just seen, which is specified in the score file, whale-say. So we're going to create an application. And in this case, we're going to use humctl, our very own CLI tooling, named in memoriam of kubectl. So let's execute this. And you can see I've created an environment of type development, whatever that means, inside of my own little organization called clearcode. So let's find out how that looks like on the UI, which is the next interface. And we're going to go directly to the orchestrator under app.humanitec.io. Okay, here we go. So you see, I'm directly being forwarded to my application called Whale because if I go to the application overview, there is just one application in here. And who doesn't like shortcuts if they are feasible? So in here, I can see I already have a development environment because not having one doesn't make any sense. But apart from that, everything is empty in here. So how does the score file get into the application? Well, usually that would be driven by a CI system. But today I'm going to simulate that step for you by executing this little shell script here to keep my pipo rate low. So what's going to happen here? We are going to actually use score Humanitec on score YAML, supply a few parameters which are coming from my environment. So I don't have to show you any secrets like token, my password here. Yeah, and then dash dash deploy actually contacts the orchestrator and deploys immediately. So you don't have to figure out on how to interface with the system and use the API. This is pretty convenient. So let's execute this shell script. And here we go. Our first deployment is already running. And now, just to make that clear, what I've shown you is Score, is a CLI, is a UI. What I haven't shown you is the last option, the API, but you've actually seen it in action all over the place because everything else is just eye candy on top of the API. Because the orchestrator is an API first system, you could have executed all of the actions directly using curl, but that wouldn't be the nicest demo ever. So I took the option to conveniently show you all of the interfaces. Right, let's jump in here and see what's happening. I see Whalesay, my service. I get the information that this workload is managed by SCORE, and if I change anything in here, it might be at no further notice removed by future deployments. And I can see that the DNS is being taken note of here. I just need to wait a little bit longer until the spinner has disappeared, and my app obviously becomes unhealthy. Now it has become healthy because now all of the containers within the replica are started and running successfully. And I can also see that my DNS has been provisioned. So I can copy that, put that into another tab, and show you that Whalesay is named like this because it's the little Docker whale saying hello. There you go. Great. So with Humanitec products, you don't need to worry about interface choice. We think that everybody should be able to flow in exactly the same way that he flows right now without needing to go to a different interface and learn new tricks or just relearn all of the muscle memory. So, but how is this actually coming together in the background? Because by me just saying DNS, how did the orchestrator know what to supply me with? Well, if I go in here, I also get this little blue arrow linking me off into the resource management system. And I'm going to jump over here because that is currently using a default Humanitec resource where I can't take a peek into. But I have a little bit more up here where I can actually take a peek into. So let's say I take a look at my trusty friend Clusty, which seems to be a K8s cluster in Google Cloud or GKE. If I go in here, I can see that currently this resource definition is not being utilized. So no actual resource is based on it. But I have matching criteria here, which say the environment type is GCP. Well, I guess I didn't specify that when I created my whale application. So I didn't specify it either when I created my development environment. I got supplied with it as the default. So how do I get something in here that actually is being triggered not by GCP? Let's have a look. Once again, there is interface choice. You could actually push the button here, but we're going to take a look at the code-based implementation. And I'm going to show you a resource definition YAML file, which is basically the specification of a resource definition in YAML format that I can just feed to humctl once again to build out a resource definition without me needing to click or type around in the interface. This obviously enables complete configurability over something that can be persisted in any kind of version control, and by that enable GitOps on the configuration side. With SCORE, you can enable GitOps on the application side along with your source code. Now we're not lacking a lot anymore to get the system into a full GitOps mode. Okay, let's have a look at how we can actually apply this file to the system. It actually works like kubectl. So humctl apply -f resource definition YAML. Okay, that actually gets me directly into the game. And as you can also see, here is a worst pattern, access key and secret, actually specified inside of the YAML, but the orchestrator protects me right away and says, okay, these are secrets here, so I'm going to replace them with references, and you will never see the value again in plain text. Good. If I now do a reload here, I should be able to see Terraform S3 because the specification was for a very simple S3 bucket. And here the environment type is development. And if I would request an S3 bucket now, I would actually be using this resource definition. Great. So is there more choice to actually define my resources? Yes, there is. You could, for example, define your resources also through the UI, obviously, but much more interesting possibly through Terraform, because Humanitec provides you with a Terraform provider. And that would look like this. So we are going to feed this a few variables which are needed, start up the Humanitec Terraform provider directly from the Terraform registry, supply in this case an organization ID and a token, and then configure our Humanitec resource definition. In this case, we're calling it AWS Terraform resource S3 bucket, and then comes some HCL code as in any Terraform execution. The only thing we're doing here is we are pinpointing a driver type, we are giving it a name and a type S3 obviously, and then we are feeding it matching criteria and driver inputs as you have seen already. And in the end, that will also create a resource definition, just like we did with YAML. So there is no stopping you in utilizing exactly the technology that you are using right now, and by that provide you with means to protect your investments and build upon your current knowledge. So you've already seen that there is a matching system behind the resources. And that is great because setting matching criteria will allow me to actually define how coarse or specific these resource definitions are utilized. Let's have a look at Clusty again. There's just one matching criterion here on environment type, which is still pretty coarse. So everything that would go to GCP would actually be deployed on top of this Kubernetes cluster. This has some implications. Obviously, it has the implication of this cluster being multi-tenant. I could actually add new criteria right here and, for example, match on application ID and say, hey, my whale application goes there, and remove this broader matching criterion. That would actually imply that I wanted to turn this cluster into a single tenant cluster specifically for this application. And through that, I can actually work on the resource utilization of my environments. But much more interesting, obviously, is the standardization factor. By setting this coarse, I can define that this resource definition should be a standard for many or even all of the applications of my enterprise. So by setting this coarsely, I can adjust the level of standardization. And obviously, I can also be as specific as I need be. And I can actually match from two sides, so to speak. Think we want to have a resource that is actually being utilized by two applications. Message bus, one side creates, the other side consumes messages. Doesn't make any sense if they end on not the same message bus, then they can't talk to each other. So all of these scenarios are covered by the matching system really well in the background and allow the platform engineers to actually specify how any kind of infrastructure is being created per environment or per context, as we call it. And why is that important? If you remember back to the start about the score file, oh, wrong directory, to the score file, you have seen that there is nothing environment specific in here. If you think about now, the resources in the background getting to be environment specific That gets interesting because it allows the platform engineers to specify later in the process during the deployment step, not the development step of the software development lifecycle, to actually add how something is built out into an environment. And that gives you two opportunities. First of all, adjust how resources are actually being built out. In development, you might run a database as an in-cluster container, cheap, easy, fast. On production, you want to have a full DB as a service thing. And you can have that, no problem, and any shades in between. And obviously, if you have configured this for one environment, you can have many of those. So not only the standard environments or stages like development, staging, production are possible, but also in ephemeral environments. Think multiple development environments, for example, per pull request. So your developers can actually test out their changes on a real system or have other people review their changes or collaborate, like back-end and front-end developers collaborate on the same actual deployment of a change without everybody stepping on each other's toes because there is just one development cluster. And obviously, you can also create very highly standardized and sophisticated systems to provide the starting point for automated test sets. And that removes a lot of flakiness from these situations. Right. Now, having said that, let's take a look at how we can actually get our little whale application from one to another environment. I'm going to go into whale and I'm going to create a new environment, which I'm going to clone from my development environment. Obviously, I'm going to choose GCP, so now I can finally use my cluster clusty, and I'm going to call this staging. Right, now to be able to deploy here, I need to actually bridge the gap between those systems. And for that, we have a feature called pipelines. And pipelines obviously has already been used to actually deploy my application to Whale. But looking into my application, I can see that currently there is just a default pipeline. There is no pipeline for manual progression. Once again, let me quickly fix that by injecting a pipeline to the system. They also can be configured as code, and this time, just for fun, I'm going to use the API. And how I'm going to do this, I'm going to use this little shell script once again to keep my typo rate low. Here we go. So I'm going to feed the curl command my token or my password to actually access our system. The content type is YAML, and I'm going to feed it my manual pipeline YAML as a post request to the pipeline's endpoint. And so the answer is nicely color coded for your convenience. I'm going to pipe this through JQ. Right, so let's actually execute this. Here we go. Trigger types, pipeline call, active. And if I go over here, I can see there is a manual deployment pipeline now, which consists of a lot of YAML code that I didn't have to type, thank God. Right, going over back to my whale application, what I can do now is I can say that I want to clone this to the staging environment. I'm going to take along all of the workloads and create a draft in staging. I'm going to directly deploy. You can see a list of the material changes between the systems, and I can take my manual deployment pipeline, give it a nice comment like manual progression, and actually execute the deployment. This is being executed in two steps. First of all, we're going to create the delta between the systems. And second of all, we're going to deploy that delta. That leads to the fact, as you can see, that this is a nicely stepped system, and you could have any amount of steps in here. You could, for example, from the progression between the environments before deployment or after deployment, in a synchronous or in an asynchronous way, which means either being able to stop or not being able to stop the deployment. Yeah. execute any kind of step, like calling out to an automated test suite and only progressing if there actually is a green light on the executed test suite. You could call out to an external policy checking agent like Open Policy Agent and verify arbitrarily complex policies. You could get manual approvals where somebody has to log into the orchestrator and actually sign off the progression to the production environment. Or you could simply asynchronously inform somebody like a Jira system where a ticket gets advanced to the next step, or call out to your enterprise architecture management system and in near real time align its state with reality. Because the orchestrator obviously has a very clear idea of what is running where, and by that, what is reality. Right, inside of here, you can see that all of the logs of the pipeline run are being populated. And as we only had info steps in here, we can see green check marks and everything is good, which means that my whale application now hopefully has made its manual progression onto the next system. All containers are up and running, which should allow me to go to the next. Oop, copied. Go to the next system and show you once again why it's called whalesay. Great. Now that you've seen this, let's quickly hop over once again to the portal UI and take a look at staging. This is a manual progression. Okay, but what actually has happened here? I could either export the manifest and get an idea of what actually happened when this deployment has been made in the background. I could diff this deploy to any other deploy or scene. I could clone it around. And this is possible because our system locks all of the deployments in in its own data store, and by that allows you to have a clear idea on what has happened when it was done, by whom. So audits are a non-issue with that. If you have more than one deployment, you can easily, by just clicking this button here, roll back to an old version. As I only have one deployment, it pretty much makes no sense to click on it now, but you get the idea. I would immediately see a diff between the two deployments, which tells me if rolling back would actually remediate my problem that I'm possibly currently seeing, and by that, get me out of the danger zone really quick. I don't even have to be a developer for that or really understand what I'm doing. I can just get my system into a stable state and then as quickly as possible, and then forward the fixing of the problem to somebody else who has visibility inside of the code base. Right. Having said that, let's have a look at the last feature I want to show you, which drives DCM as well, and that is the secrets and the values which are part of the system. You have already seen that there is inside of the whalesay application, inside of the container, a key named hello with a value named bird. But this one is specific to just this container. But I could also have shared app values in app default values and secrets. If I go on here, I can see currently there's nothing, but I could add something. For example, I could say that my friend is actually Humanitec. Yeah? And I could, just to demonstrate you this, add something by typing dollar curly brace from the environment. Yeah? So you can see here, I can use those references. Let's not do that for the moment and just stay on this example. I could also turn it into a secret, but our friend is called Humanitec. And now I have on an application level a key named friend with a value named Humanitec. That is interesting because now I have a, once again, general sensible default for that. But if I wanted to be a little bit more precise, like in development, I've deployed manually, but using score, so I want that value to be different. I can go into the secret and value overrides and specify here that this key with the value friend, this key friend with the value Humanitec should be, in this case, actually score. And I can save that. And now I see it has an override for this environment, which overrides this to score. And so I can actually care for our configuration in a very intuitive and quick way without having that in the score file. Now that you have basically seen all of the touch points that DCM has inside of our different systems, you have seen score or different products. You have seen score and the workload specification. You have seen the portal with the UI, and you have seen the orchestrator doing all of the work in the background, the heavy lifting, all of the functionalities visualized through the portal and being attacked by the other interfaces. Yeah, you know that dynamic configuration management is actually driving all this. And it's the reason why everything is so simple for me. Yeah, I can specify my application in that really simple way in my score file. I can specify my resources in that really simple way because once again, they are just specific to one context. Yeah? And I can use any kind of infrastructure as code in the background, yeah, and interface that with my developers' wishes. And the orchestrator cares for the fact that everything happens fully automated without manual intervention in a self-service way available for developers. Nevertheless, I cannot go into full breadth or depth of the topic of DCM. So if you would like to, please reach out to us and book a demo with a platform architect like me, or actually watch into all of the other capabilities of our products. Thank you for considering Humanitec and have a nice day.